All right, so here we are at the first of our notebooks that we're going to actually be running for this training. So as I said before in the intro to the workshop, to the training, and also to Zeppelin, that one of the first tasks for us is to basically take a look at how we load and query data in the Spark environment. So we're going to go through that right now, and all I have to do is click Load and Query. So Load and Query is going to basically ask you what interpreters you want to be bound to the notebook on the first time through. This is going to happen for every single note that hasn't already been run through at least once. So before in the intro I was talking about binding an underlying interpreter to a notebook. This is all that is right now. So we're saying, okay, I want Spark and I want Markdown. I'm going to basically just turn off everything else. Bear with me while I'm doing this because it takes a while. So there's a lot of different interpreters, as you can tell. And one of the nice things about Zeppelin is that it's kind of just like a polynote, polyglot type environment that is capable of really binding to almost any kind of backend or language. In this case, you can run Spark on Scala, or you can run Spark on PySpark. You can run Python, you can run scikit-learn, etc., all in the same notebook environment, which is kind of cool because you can bring in the best of every kind of framework in one environment and kind of collaborate with multiple people within an organization as well, which is really nice. All right, so the first time through in any one of the notebooks, what we have to do is basically run one paragraph or all paragraphs in order to get things actually bound. So we bound an interpreter, but we haven't actually started it. So what we're going to do is we're going to click the start button. This is going to basically spin up Spark. It's going to configure Spark and then also bind it to the notebook. The same Spark environment is going to be used across every single notebook, which allows us to basically reuse any of the data we've imported from any of the prior notebooks in any of the other notebooks as we kind of go through. So if you think about this as an ordered training from note 1 through 5, everything is basically reused across the board. So there is a little bit of a kind of a startup gap before getting started, which is completely fine. It's a normal process that happens every single time you start for the first time. One of the interesting things also that I wanted to point out is that in order for us to be able to have Redis bound to Spark in the Zeppelin environment, we've actually done some kind of magic behind the scenes. So if you take a look at the Docker Compose, one of the interesting things, so we have our Redis environment over here, we've got our Zeppelin environment, and then we have the Spark submit options. So all the Spark submit option is saying is that every time we create a new Spark, a new connected Spark or a new Sparc Session, we also are requiring the Spark Redis library to be available in our Java class path. This way we can use anything that's actually been anything from the Spark Redis library directly in Zeppelin without having to worry about bringing that in ourselves. So because it's done behind the scenes, it allows us to do everything directly inside of Zeppelin without having to actually really call anything in. So it feels natural. And it's the same thing that you would do if you're creating, say, a jar, and you're just bringing in the Spark Redis through a POM dependency or through an SBT dependency for Scala. All right, so first paragraph is basically just giving you an idea of everything that's available within the Spark configuration. You can literally glance over that now, you can glance over it later, you can never look at it, and that's all completely fine as well. It just allows you to see like everything that's available within like that, the class paths and everything else. So, all right. So what I was saying before is that our first real priority in this first notebook is to really learn fundamental foundations of how to use Spark and Scala, and also how all of this stuff works running on top of Redis. So this notebook is going to literally go from the process of importing data, which is from our Netflix movies and shows database from kaggle.com. And for that, for this first paragraph, we're going to take a look at the end process of cleaning up data itself. So I'm going to basically talk about the end process because this is more of like a sidebar for anybody who actually wants to go through the process of actually getting the CSV data from Kaggle ready to import into Spark. So I have this Netflix titles raw, and then I have Netflix titles formatted. So the raw data hasn't been formatted, and so it's kind of a spelunking journey for anybody who wants to take that journey. Because of time, all I've done is basically not kind of follow the typical kind of cleaning process, but kind of just show the end results of what that actually looks like. Because it can be kind of problematic, and it's also hard to share in the notebook environment because there's a lot of actual work done directly on the CSV to ensure that imports are imported correctly. But with that out of the way, we're going to basically take a look at this whole entire paragraph. So we have this base path. And then there's one more thing as well. So in the base path, we have this /learn. So /learn is actually just this data directory inside of the actual Docker runtime. So all we've done is basically symlink data to Zeppelin. So I'm going to show that real quick, and then we can kind of move on with our lives. So if we go into the environment for Zeppelin, we'll actually see volumes. So volumes, we'll see that we're basically passing our current directory, which is the Spark Docker directory. We're passing that data to /learn. So this allows us to basically have a directory where we know our data has been loaded, but it also allows you to dump more data directly into the learn directory. And then every time a Docker container is actually stopped, you don't actually have to worry about re-importing all the data again because it just exists there. So this is actually the trick for how we got notebooks up and running as well, because I've already written the notebooks. You don't have to worry about importing them because they're actually available locally in the directory as well. There's a directory called notebooks. So taking a look at that over here as well, we're basically forwarding our notebook environment and just having it be /notebook. So this is actually a nice trick to be able to create an environment that feels like it's running on your laptop while it's running in a Docker container without having to worry about everything being swept away every time you want to stop running your Docker instances, because they can take up a lot of CPU and RAM from your machine. So if you're doing more than just running Docker on this machine, most likely you're going to want to stop it afterwards. So with that out of the way, we have our Netflix data. So all we have to do is basically take this Spark variable, which has been implicitly defined and injected into the notebook environment. And all this is something called the Sparc Session. So the Sparc Session is actually giving you all the functions that allow you to either read in batch, like we're looking at right now, or also read a stream, or write a batch, or write a stream of data. So it's either spark.read or spark.read stream. And then there's a lot of different sources and sinks. So a source being a source of data, a sink being a place where you're going to basically, write data to. So we'll take first look at just Spark read. So Spark read, option header true, infer schema true, with UTF-8 encoding, our Netflix titles formatted. This is a CSV file from Kaggle. So I'm going to run this note. So I'm just going to zoom back up. So running the note right now, and this is going to spit out some stuff to standard out after everything's been loaded. So it's running right now, and now it's finished. So first off, we're going to take a look at our schemas. So schemas are super important, given that a schema defines the data that you're actually working on. So if you think about CSV being string values that are comma separated, we've now actually imported data that is not just a string value. So what we've done when we said infer schema true is allow Spark to actually infer and figure out what the schema is just by testing it. So if you've used like Jackson for JSON in Java before, or any other kind of, any other kind of library that's actually, deducing actual value types, it's the same thing as that. So Netflix data print schema. So we're taking a look. We have a show ID, which is just an identifier for a show like Breaking Bad. We have a type, which is going to actually be a movie or a TV show. I didn't know that on my first time through, but it's also an interesting, it's an interesting thing when you're going through data for the first time and you're kind of exploring or spelunking, playing detective over that data to figure out exactly what each type has, like what each type holds. What is the cardinality of type? In this case, it's 2. Titles is going to be a unique title per TV show or per movie. Director is going to be one or more directors, and this is going to be basically a comma-separated string, which requires further processing if you want to actually work on, say, linking directors to movies to find, say, commonalities between the movies that certain directors work on. Cast is one or more cast members. Same process there. We have a string value. We're going to have to actually work on exploding out the string to be able to get the cast members. Country is country of origin of the actual movie. Date added is a value that may or may not actually exist in the data set, but this actually tells us when Netflix first adopted this movie. Release year is the release year of the actual movie or TV show. Rating is not the rating as in the star rating, but this is actually the rating, from PG-13 to PG to TV, Y7, etc. Duration is that string value that is in either minutes or in seasons, which is interesting, and we're going to take a look at that a little bit later to try and encapsulate, more of, total number of seasons or total number of minutes or average minutes, like all sorts of fun stuff that you might need to understand in order to ask more of your data. And if you think about machine learning, really what we're doing is we're asking the data to predict a specific pattern. Machine learning is good at pattern recognition. Humans, we understand patterns visually better than we do through data. Machine learning doesn't really give a shit about the underlying, excuse my language. It doesn't really care about the actual, visualization because it can't see, but really it cares more about the actual underlying data. So, inferred schema is the next part. So we have release year, we've got rating, we already talked about all of that. We have the schema, which we're going to take a look at in a little bit as well. And then we're also going to talk about temp views. But one thing I wanted to say before we actually get into temp views is that, how is it that Sparc SQL is able to do what it's doing? All it's doing is actually taking our data frame, and in the case where we say create or replace temp view, sorry, that was a bad highlight, but if we say create or replace temp view, all we're doing is we're creating a temporary SQL table over our data frame. So this allows us in the future to basically use SQL to directly query our data, which is great. So, and then, if you think about databases and like if you've ever used SQL before, one of the things is, what tables do we have? From those tables, how do we describe what is actually in that table? And all this stuff is also baked into Sparc SQL as well. So when we say Netflix raw, so Netflix data creator replace temp view Netflix raw, we're making this table available inside of our default database. So we also say show databases, and we'll actually see that there's only, we'll have a global database, and then we'll also just have a temporary one as well. So here we go. Database is just our kind of default. Table name is Netflix raw. It's temporary true. So as soon as the session is destroyed, this table will be gone, which is great because in this case, it's only here for show. All right. So that is basically the process of just reading data in as a data frame. And we're going to take a look at what the data looks like in just a sec. But first off, we're going to also take a look at what is it underneath the scenes that, how do we describe a data frame? And we talk about this inferred schema. So when we say Netflix data, which is our data frame, and we say schema, we're actually taking a look at something called a struct type. So I take a look at the inferred schema, and then I basically just run this over here. All it does is it basically spits out the underlying structure. So this struct type itself, if you were to basically format this, that's all we're seeing in this next paragraph. So here we go. So strict schema allows us to basically see that we have a show ID, it's a long, type is a string, title is a string, etc., all the way down to our description. All right, so that is basically kind of like the very, very, if you think about, the primitive steps that you would take in using Sparc and Sparc SQL and understanding kind of the data frame itself. We're now going to move on to how is it that we actually apply these, a stricter structure to our data. And this is important in the case where you, say you have different value types and you have maybe say it's a short or it's an it's an integer value, or maybe it's a long value, maybe it's a float value. When you infer your schema, Sparc actually has to make that decision for you to figure out what actually fits the mold better. So in the case where you really want to explicitly declare something as a float value, you can update your actual struct type. And then from there, when you're actually loading your data, you're forcing that initial casting from one type to another type. So what we're going to do is, instead of inferring our schema on the second import, we're going to look at actually just re-importing the data and ignoring schema and using the struct type that we just declared above. All right, so here is what we have right here. So now we have Netflix data strict. doing everything that we did before. I'm introducing a couple more of the options, which are literally, there's many different options that are available for kind of parsing CSV. Most of them are kind of normal standard values, but depending on the type of separators that you have in your CSV, maybe it's a tab, maybe it's the comma like we have in normal CSV, maybe it's something like, double colon or something like that. Depending on how you've actually formatted the CSV for import, this is all really important for actually parsing it back into Spark. The main thing, though, that we're looking at right here is our ability to not infer our schema. So we say option infer schema false, and then for our schema, we're actually saying I want to use the strict schema that I just defined up above. And then all we're doing is basically re-importing this initial set of data again. So where we had Netflix raw before, we're going to now say, okay, well, we're going to let Spark read the data frame. So parse the CSV, create the data frame Netflix data strict. And then all we're going to do is create or replace this temp view for Netflix. So pretty much exactly the same thing that we did before. But all we wanted to do is basically do this with a strict schema versus actually defining our inferred schema. So now we've created the same exact data frame that we had before. And then all I'm doing over here is basically using the describe function of standard SQL to describe the table that we just defined in the create or replace temp view Netflix. So over here we see that we have a show ID, big int, type. It's exactly the same thing that we described in our struct, but this is just showing how the SQL interpreter inside of Spark actually understands the structures that we've actually applied to our data frames. So pretty straight, simple, and we'll kind of move on from there. So we have our tables, we have the ability to run SQL. So now we actually have this new type that we haven't seen before. So we have modulus SQL. What this does is allow us to actually use the data that we defined in our temporary view, and now we can actually do some interesting things with the underlying Zeppelin application. So because Zeppelin understands SQL, we can actually now graph our data to inspect it. In this case, we're just taking a look at a table view, which gives us an idea of what data we are working with. So show ID, TV show, Transformers Prime. There's no director, it's a null value. The cast has a bunch of cool people in it. It's from the United States. It was added in September of 2018, but it was actually released in 2013. So maybe there's, maybe that's some kind of pattern you care about. It's got a, young adult 7, I guess. I don't know what the FV stands for. And it's a duration of 1 season. Cool. So this just lets us basically take a look at a non-CSV view of our data because it's easier to actually kind of look through here. And also you can take a look at taking a look at, alphabetical ordering or reverse alphabetical ordering of all the data without actually having to write that in your SQL. We can still write it in the SQL, which we're going to do in a little bit as well. We're going to take a look at how to do a lot more just by writing SQL queries. So this is kind of for like the, the BI experts or the SQL experts like in like a group that you're working with. This gives them the ability to use what they're comfortable with. Or if you want to actually use the Spark DSL, you can use that as well. You can mix and match, and it's all great. All right, here we go. So before I said that we had 2 types for our actual, for the underlying type in our data. So all we have right here is basically just proving that we have 2 types. So before I didn't know how many types we had. So one of the things you want to usually look at is, basically what are the distinct values that you have for a specific type? And then also, like, what's the cardinality of specific types of, say, shows in this case or movies in this case? How many do we have? We might also want to take a look at, how many movies were maybe released per year? Is there any kind of information that we can actually apply, to kind of like our journey and our exploration? So remember, we're wearing detective hats here. We actually want to find out more about our data before kind of moving forward. So let's be data analysts for a bit. So we have our distinct types, we've got TV shows, and we have movies. In the next paragraph, we take a look at basically just our count query. So selecting count as total, type from Netflix, raw, and we want to group by type. I'll run this to make sure that it's actually running, because it should be running, great. The other thing too is that the Netflix raw, we don't really care about that too much because we actually re-imported everything as Netflix, so we'll just fix this over here. Now I'm going to run this and it's basically going to run, and now we have more information. So we have almost 2,000 TV shows, and we have a little bit over 4,000 movies that we can actually play with in our data set. Great, we know a little bit more about this. All right, So some of the other things that you might want to do too, if you're taking a look at, say, finding out more about the subset of some data within your data, think about this as applying to problems outside of the Netflix data set, and showing you some of the interesting DSL options that are available within Spark. So we're going to create now a new data frame from our data frame, which was Netflix data. So clean types is now Netflix data. We're going to select everything where the column type is in the collection sequence of movie and TV show. In this case, given that we don't have any other types, it doesn't really matter. And this is more of just, kind of an example row of data. So all this does is basically take everything that's bounded to movies and TV shows, which is basically 100% of our current data set. Great. But the other interesting thing that we can do here, aside from getting like our clean counts and like our actual count of all of our data, is take a look at basically creating intersections. So if we have this Netflix data strict, and we want to intersect our clean types where our column type is equal to movie, we can create an intersection. TV shows, we can then say, use the intersection across where things were movies, and then now I want to take our root data, and I'm going to run an except query on it. So the interesting thing here is that this is just one way of saying like a not clause. So Netflix data strict, where it's not a movie, is now this intersection that is now TV shows. So this is more of like, how do I use the DSL, and what kind of interesting things can I do, so I can kind of build my Spark chops. So this is really another way of taking a look at a table view, which is really ugly. So TV shows sort asynchronous by show ID and now show. This is super hard to look at. One of the things you can do from here is basically say, well, we have our TV shows. We still want to sort asynchronously by show ID. But now we just want to create or replace our temp view and then say TV. Now we're going to run this. Do TV shows. And now we have our temp view and everything has been run again. So now if we want to take a look at just adding another SQL table, take a look at what we had that looks a little bit better than what we had for just the show, all we have to do here is just say, select everything from TV. This will run for a little bit, and now we have our TV shows, TV shows, TV shows, TV shows. So we get it. We were able to do an accept on our movies to be able to create a subset of our data, which was TV shows. Interesting. How can we do that in a different way? So this is basically a SQL-only way of doing the following versus what we did, before, which was using Spark DSL. So we're going to now just say, I want to select everything from Netflix where the show ID is not in the selection of all show IDs, which are movies. And now we want to order by show ID and take a look at the first 10. So this is exactly the same thing that we did before, only it's doing it in a manner that's a little bit easier to understand than our intersection and accept clauses. So all the same stuff again that we had before, just another way of doing the same exact thing. All right. So moving on. So we understand now that we have TV shows and we have movies. We also know that from our initial investigation of the underlying structure of the Netflix data that we have this duration clause. Not duration clause, but a duration column per row. And one thing when you're taking a look at data for the first time and you're investigating is to try and figure out what does it actually mean? Like, what does it mean to say that we have a duration for movies and a duration for TV shows? So one way to do a quick investigation on any individual column in your data, in the data frames across all of the individual rows of the data frame, is to do this describe function. So what we're doing over here is we're saying Netflix data strict. We're selecting only duration from all of our columns where the type is equal to movie. So duration across movies, and now we're going to describe this. And now duration across TV shows, let's describe this. Also, taking a step back for a second, when you're cleaning your data and you're looking for problems with import, this is actually a really interesting thing that you can do, because if you expect the duration to always be a string, sometimes you'll notice that it's not actually a string that shows up because the commas may be out of place, or maybe there's some kind of botched formatting somewhere else, like within the underlying data set. So we're looking at the cleaned data right now, but if you were to look at the Netflix raw data, you'd actually see that your first time through duration, you'd actually have mean and standard deviation across not just string values. So you'd actually see something a little bit more like min value of 10 minutes and maybe max value of like 100. And you're like, wait a second, that doesn't make any sense, or it might be a name in there. So when cleaning data, it's a nice thing to be able to kind of go through and ensure that there is correct separation where you're expecting the separation on that underlying data set. And a quick way to do that is to use describe. So count, we've got 4,265 individual records for our individual movies, with a min of 10 minutes for a movie and a max of 99 minutes for a movie. We know that movies go longer than 99 minutes. In this data set, it doesn't. But it's a nice way of taking a look at min and max values. Other interesting thing too here is that min and max in Spark can also apply to actual character arrays. So in this case, we have lexicographical ordering. Same thing over here, 1969 of our individual TV shows in the data set, and min is 1 season and max is 9 seasons. Great. We're understanding a little bit more about the data that we're working with. All right. So now we're going to start going into stuff that is a little bit more kind of, I guess, interesting from the point of view of the Spark DSL. And what this problem is actually solving that we're looking at next is the ability to basically add to the data that's been loaded. So we know right now that we have a data frame, we have our data that's been imported, and it is a data frame, and it has specific rows and specific columns per row. But one of the things that it doesn't really have right now is a nice separation between the duration types, or what is it, the numeric type of the duration, across movies or TV shows, and then what can we do with that actual date time? So we know that date added exists in most places, and this is can give us a way of kind of separating the release month, the release day, across the data frame that we have, to maybe inspect a little bit more of the data to say, how is, say in this case, how is Netflix handling releases of different types of TV shows? And how is it that, how would we do anything with this? Like if we just have a string value, we know that we have to parse it. And to parse it and then cast it, to a timestamp, that process should be done. And that's what we're going to do right now. So I'm going to kind of walk through exactly what's happening. So we're saying Netflix with time dimension. It's a little bit more than just time dimension. So what we have here is we have our initial data frame, so Netflix data strict, which we imported above. We're now saying I want to add a column called duration type, and then when the column of type is equal to movie, let's actually add 0. Otherwise, let's add a 1. So now we just have a binary field that is our duration type. So we can use that if we want to say, take a look at all movies and then do a breakdown on the actual numeric duration of those movies to see, okay, are movies more around 60 minutes, maybe 121 minutes? What does it actually look like? And then this might be a way of if you were, say, working at Netflix, you could use this to basically figure out, okay, well, what's more popular? Do people really like long duration movies? Do they like short duration movies? If somebody, potentially is only watching movies less than 30 minutes, or TV shows less than 30 minutes, should you recommend something with longer content, shorter content? It can be used in many different ways. Like in our case, we're just using this as kind of a practice problem to take a look at how to actually mutate our underlying data frame. So that's our duration type, duration numeric over here as well. So duration numeric is actually a little bit more complicated. So we're saying we want to add a new column across all of our rows of data. And then all we're doing is basically creating a function that's going to apply, and behind the scenes with column is going to iterate over all of our data, and it's going to mutate it. So every time we say with column and then with column, all we're doing is basically chaining functions that now create an immutable kind of end type. The nice thing with this is that immutability means that you have a kind of finite data set that won't change in memory. You can create a new variable to hold a mutation or transformation, but everything's actually sealed. So that's what the val keyword actually stands for. It means this is immutable once it's actually been generated. So Netflix data type, we're adding duration, or Netflix data strict, we're adding our duration type, we're adding numeric. So when the column type is equal to movie, we're creating a regular expression to replace the column duration. And all we're doing is basically removing that space minute and replacing it with nothing. Otherwise, if it's not a movie and we know it's a TV show, we're basically going to replace the column duration with either a season or seasons keyword. And we're going to basically replace that with nothing. So where season or seasons, replace it with nothing. And now all we're doing is saying, well, we now have a numeric data as a string. Let's cast it as a double. So now we have duration numeric, which is a double type. We're going to do the same thing with date time. So we have a column called date added. Date added needs to be cast as a timestamp so we can work with time. So we're saying date time functions comes from our, I'll just show the import over here. So org Apache Spark SQL functions. I'll just make sure as I run everything else beforehand, otherwise some stuff could break. All right, let's run that. Okay, going back over here. So I'm just gonna run this. So Sparc SQL functions gives us the ability to call something as a column, also to use a regular expression replacements, and then also gives us this function to timestamp. So because we brought in functions, we can actually now just call this to timestamp just to show how all this stuff works. Great. So all this is doing over here is saying date added. I want to parse the format from the underlying date added to create a date time object. We're also going to be able to create a release month by taking the date format of this formatted column date time. And we can actually do all this chaining because every time we add a with column, as I said before, we're actually doing basically synchronous series of functional transformations on that data. So at the point where we're now saying with column release month, the column for date time has already been added, which is kind of nice because people can understand the series of transformations. This is also something that's actually handled later on in what we call a transformation pipeline. But for now, just consider this as a series of functions applied to the underlying data frame. So date time month we care about for our release month. We're going to cast it as a double. And then also release day. Getting rid of the functions over there. So date format column for day. So play that one more time. Made sure we didn't screw up anything. And one more thing too that I'm going to also talk about is our data description language. So if you've ever created a SQL table, you've done create table, and now you have all these different types for your table. This is no different. So the DDL is a way of actually taking our schema, which was applied to our data frame, and now we can kind of export it as a string. And then we're going to see later on in the tutorial how to actually import that to quickly create the structure for our import data, versus having to sit there, and define an entire structure like we did at the top, where we had struct type and we had show ID, etc., all the way down. This is just a quick way of taking a string or editing a string and then using that to apply it for a strict import. So DDL, new table DDL we'll use later. So Netflix time dimension. What we're looking at right now is taking our data that we just mutated, and we're also taking a look at nullability checks. So aside from figuring out what the cardinality of each row is and what is the specific number of distinct types, we also care about nullability. So over here we're saying how many times is rating null, so 10 times. Also, how many times is date added null? 11 times. So now if we say we have this Netflix with time dimension where the column date added is not null, this is allowing us to basically take a subset of the data where we actually have all date added available for us. When taking a look at the column date added where it is null, so you can basically flip this whole entire expression around on itself. It lets you basically take a look at the TV shows where we don't have a date added. So either it's a bad import or it's just a free data set. So sometimes things are broken there as well, which is completely fine. This is just a way for us to be able to work with the data that we actually want to work with. Next expression we're going to see is this NA fill. So we know that we were missing 10 ratings. And what we're going to get to in the actual, the build up to what we're learning through our machine learning process is that we're going to actually build up to creating a model that identifies whether or not a movie or TV show is kid safe. So ratings actually matter a lot for us to be able to say, is a show kid safe or not? Also, the categories actually matter for the TV shows too. But there is actually overlap in TV shows that are kid safe and not kid safe under the same category. So as a pet project to show you the process of creating machine learning models on top of Spark, this is actually a really kind of fun problem to play with. We're going to get to that in some of the next tutorials. But let's take a look over here. So NA_fill unrated for the sequence of rating. So over here we're saying I want to take the data frame and I'm going to fill everything inside of the sequence. And a sequence is no different than saying like an array. And this basically just takes the column rating. And you could add many different columns here as well. So say you wanted to fill all null fields with an empty string. You could do that as well if you wanted to. In our case, we want to be very specific about how we fill a column with this unrated string, so UR. So NA_fill across all ratings where it's unrated. So if it's null, make it unrated. And then we're going to basically create this new Netflix dates temporary table. So run that over there. Great. We now have that. And then over here, this doesn't really matter that much, but just another way of basically selecting with now using a min clause. So we're going to select the min release month as min month, max release month as max month from Netflix dates. This is also an interesting thing too when you're cleaning the data, because if your expectation of your months doesn't show up correctly, or you find out that you have a min month and you have a max month that are, say, less than themselves. So it's actually possible to say min month is actually greater than max month, depending on what you're working with. In some cases where you have values over, greater than 999, and they show up as string values, it'll actually show up as a larger string. So if min value is 99 and max value is 999, sometimes the things can get flipped around. In this case with min and the max, we've actually already treated the data. We've cast it to a double. So this is actually just showing you a way of using min and max functionality within SQL from Spark. Okay, great. So it's still showing up as min and max. That's wonderful. Okay, so this whole entire journey of exploration so far is showing very basic transformations and functionality that Spark has to offer, which are all kind of part of the pre-processing data cleaning path to machine learning. So given that you've never looked at the data set before today, maybe you have, but let's pretend you haven't, and I had never looked at the data set before today, which I have, but let's pretend I didn't, then this whole entire process is part of that kind of initial exploration. So if you think about this as kind of declaring like, what do we know about the properties of the data? Then we're going to take a look at ways of speeding up what we just did as well, by not necessarily doing as much first and just trying to use the baked-in functions from within Spark. So let's say we have this Netflix with time dimensions. We want to describe it, and then we want to create data properties. We also have the Spark SQL. We want to describe Netflix with dates, and we want to create the table properties. So these two methods, all they do is basically allow us to take a look at underlying data frame properties or underlying table properties in a manner where we can actually quickly turn it into a table. So taking a look at the table properties, we already knew about show, type, title, etc. But now we also have our underlying data type, which is 0 or 1. We have our duration numeric, which is a double, date time, which is a timestamp, release month, which is a double, and release day, which is a double. Great. That worked out perfectly. If we now want to take a look at selecting everything that's available from our data properties, what this has done is now created a new kind of pivot around all of our individual column types across count, mean, standard deviation, and this one's not scrolling down well, but there's also like a min and a max value down there too. So across the show ID, we'll see that we have in show ID, since it's numeric, we have a mean and standard deviation. Type is a string value, we don't. And you can take a look at this, at your own leisure as well. It goes across every single one of the underlying columns in the data frame. And it's a nice way to just kind of quickly explore the underlying data. All right, and then from there, here's just basically a way of saying, okay, I want to project my data. And the process of projection in SQL is basically saying, well, let's take all of our rows, but I really only care about this row and this row and this row. So let's cherry pick that actual data, only bring that down, and now let's take a look at it. So that's all we're doing here. So we're selecting duration, duration type, duration numeric from our Netflix dates. So all this is doing is allowing us to say, okay, well, have we actually imported correctly? Did our regular expressions actually work? And across the board, they did. Yay, that's great. So let's run this. Yay, it worked again. Awesome. All right. So at this point, we've taken a look at importing our data, and we've looked at how to actually automatically infer our data types. We've taken a look at something I like to call steal the schema pattern. And steal the schema pattern says, well, if I've imported data and I've actually used the inference, now I can actually steal the schema, and then I can use that on the next time I import to basically have a strict schema that I actually expect. So this data expectation is really super helpful when you get to streaming. For right now, given that we're in batch and we're playing around and we're exploring the data, it doesn't matter as much because you have the ability to kind of change quickly in that whole entire process. So say you don't like something or you want to add something else, great. By the time you get to streaming, you want everything to be sealed. So the ability to actually have these structures is super important. You'll see that the DDLs actually matter as well as we move a little bit forward because it's a quick way of applying a strict schema. But everyone's here for Redis. We're also here for Spark and machine learning. And this is actually the first intro to using Spark with Redis. So before we took a look at importing the Sparc Redis library. And the Sparc Redis library itself gives us the ability to do exactly what we're doing here. So this fancy little write with format is part of the actual, let me have a quick drink. So the write capabilities are part of that Sparc session. And as we said before, Sparc Session allows us to read in batch, read as a stream, write in batch, or write as a stream of data. All this is doing right here is saying, well, we want to actually take a sink that is Redis, and we actually want to write our data frame to Redis. So we're taking a look at two different types right now. So two different modes of writing, and also two different options for how we write. So right over here, we say Netflix with time dimension. I want to write. Our format is org Apache Spark SQL Redis. Mode is overwrite. Well, what does overwrite do? I'll tell you. Overwrite says every time we have a key collision, we're going to overwrite it. If you say error if exists, which is another option for mode, then when you actually go to overwrite, it's not going to work. So we actually have an example of that down here for you to test out on your own. So if the data exists, it won't overwrite it, which is really, really nice in the case where you expect not to overwrite data. So you're filling data and something already exists, and maybe you've been doing like a replay in your data. You want to figure out explicitly how to fill in the gaps of what data was in place before without actually blindly overriding it. So in this case, Spark gives you options to either overwrite explicitly, append only changes, or error if exists in the case where you actually have new data showing up. So we're now going to create a override mode. Our table is going to be Netflix. Our model is going to be binary. And so what a binary model is, it says, well, we have a data frame. Let's apply Java serialization to be able to take the entire data frame and compact it into binary data to throw it into Redis. So if you have a data set that's a lot larger than, say, 6,000 items, which we're looking at over here, then the ability to basically say, well, this is all kind of binary compacted as well as it goes into Redis, that just gives you a way of kind of compressing more data into a finite amount of resources that you have in Redis. So given that you're keeping everything in RAM or in flash memory, it's really nice to be able to basically compact as much as possible. So binary compaction allows you to do all of that. And then also we're taking a look at key column. So in this case of show ID, given that show ID can be used as a unique identifier for a specific show, this is also perfect for us to use as our key column for our underlying data. So all this will do is basically create a Netflix data table that has a key column show ID. So let's run this over here. Yay, awesome. So it didn't crash, which is good, which also means that the data is in Redis because we're using the Sparc Redis adapter. And then behind the scenes, we were talking before in the initial intro video that we have this Docker network. So we have the Spark Zeppelin. I can't really do this well. So Spark Zeppelin over here, Docker network. Sorry, it's all backwards. And then over here, we actually have the other environment. So all we're doing is basically creating like a connection across two Docker containers to enable us to be able to write to Redis and also persist Redis outside of Docker starting and stopping back up again. So in the data directory that we talked about before, which is actually /learn inside of the environment, you'll have a dump.rdb, which is the actual background save of the Redis database. So if anytime you want to kill this whole entire process and start back up again, you don't have to actually run everything over again. It's actually already exists in Redis, which is nice. All right, so this is our binary model. So binary model is nice for compaction, but might not actually be nice for doing kind of any kind of push down. And typical push down means that, in the case where you want to say project data, like we took a look at before with getting like the duration and the duration numeric and duration type back out, you might want to basically take, say, show ID, you might want to take the rating and maybe a category, which we'll look at later. If you're using the hash map, which is basically part of the hash set functionality within Redis, then you can actually specify exactly which keys you want across the hash map to be able to basically fetch that stuff back out. So you basically have like an HM get or HM set. And so in this case, if we basically use the default instead of the model binary, over here, we'll actually create a normalized or normal Netflix data set. So I'm going to run this now. So Netflix with time dimension, and now we're writing back to Redis as Netflix norm. And our key column is still show ID, and we're still going to do an overwrite. If you want to add a time to live, you can add a time to live as well in seconds, and then things will disappear after a certain number of seconds. All right, so let's pop up our window again. And all we're taking a look at over here is the ability for us to take a look at Docker. So we're going to use this. Let me increase the size over here so everyone can see this. So Docker exec.it Redis 5, which is the host name and also the Docker container name of our Redis. And then we care about our Redis CLI. So now we have a Redis CLI which is running inside of our Docker container. So if we want to take a look at what keys are available, remember that using keys in a production database like this is bad because it's going to have to scan over every last key, and it can be a performance nightmare. But in our case, we don't have too many keys. So now we can take a look at the different types of keys. So we have Netflix, norm, and just regular Netflix. So remember that Netflix, without the norm, was our binary data. So if we want to do a key across our Netflix data, we'll see that it's definitely binary. If we take a look at our Netflix norm, we can see that the type of the key is a hash. So then if we do our key, and then our field is, say, show ID, we don't have the show ID, so let's take a look at duration. So we have 131 minutes. So the interesting thing there is that because the show ID is part of the actual key, it's actually not added to the underlying actual hash set, which is really nice because why add more data if you don't need it? Because it's already part of the key. So it's a nice optimization that Redis has done behind the scenes for you. So you don't have to really worry about the additional overhead for some of these larger values like you have for like a show ID, given that it's going into the actual underlying key space as well. And so it's going to have its own kind of optimizations there. All right, so that is pretty much it. If you want to go through and debug the object for Netflix norm as well, you can do that as well. Also, if you want to remove all keys and start again, you can use the flush all command. Again, don't use flush all in the case of a production environment because you'll kill everything inside of Redis. So it's kind of bad. All right, so that's pretty much it for this first part of the training. And I hope that you've enjoyed this so far. I know it's, for anybody who's used Spark or Scala before, this is a very, very, very slow start. But for people that have not yet done anything with Spark or Scala before, hopefully you understand a little bit more about how to actually use Spark and Spark SQL along with Redis. And as we take a look at the next few sections of this training, we're going to take a little bit more about how do we explore our data. And that's what we're going to look at next, followed by how do we transform and feature engineer our data? How do we model using different predictive analytics models like logistic regression, linear regression? Then lastly, how do we create pipelines and then also take all that stuff online through streaming? So thanks again, and I'll see you next time.